Hello and welcome to another round of OAuth Happy Hour. I'm Aaron Parecki, and we're here again with Micah Silverman back from the break.
Welcome back.
So if you are joining us on Twitch or YouTube today, feel free to drop questions in the chat at any point. We'll happily take questions from you all who are watching. Otherwise, we will just be chatting about whatever we are going to talk about what's new in the OAuth world and what are some new developments, what's going on there. And yeah, should be a lot of fun. So glad you could join us.
Yep, good to be back.
So yeah, where should we start? Should we start with some updates from the OAuth world?
Yeah, maybe catch us up. What's been happening since the beginning of the year?
Yeah, the OAuth group has had a couple of now interim meetings since the beginning of the year. Let me see if I can share that screen in there. Yep. Or rather, we're about to have a whole series of them, and we did have one last week. And these are the official IETF meetings, for the group that are documented on the record. This is where things can get brought up to the group, either current specs that are in progress or new specs that are being introduced. And rather than try to cram everything into the IETF week, which just happened, IETF 110 took place virtually, would have been in Prague in person. And instead of trying to cram all these topics into sessions during that week, the OAuth group has decided to meet outside of that week and instead is running these as weekly meetings for the next 6 or 7 weeks. So the last, or rather Monday, was talking about DPoP. So that was the topic of that session. And we've talked about this spec a few times, I think, on here, but it is still in progress, still working through some that's how it goes. So there were some new things to talk about, a new version published shortly before, I believe. Oh, no, did not publish yet, but there were some changes being discussed on the call. And I unfortunately had to leave shortly. I could not stay through the end of the call on Monday. I had another thing to run off to, but yeah, that's
process-wise. It no longer has like an individual's name attached to it, so it's been adopted by the working group, right? Is that the part of the flow that we're in at this part?
Yeah, exactly. So a lot of these will start out as what's called an individual draft, where it just has a person's name in the URL. And that basically, like, anytime you see one of those, take it with a grain of salt, because literally anybody can publish those and they don't actually mean much at all. It's just a way to get a document shared, published, date stamped, on the record officially, all that kind of stuff. But it doesn't have any official standing until it's adopted by a working group. Once it's adopted by a working group, then the URL changes to the name of the working group. So, for example, it's hard to see in this one because the name is the same length as the word IETF. But here is the individual draft from Daniel Fett, and it went through several revisions as an individual draft, and then it was adopted by the working group in April 2020, and it was renamed to Draft IETF. And new versions were published there and there.
Neat. Yeah, and so we have talked about this a little bit before, but what I'm curious to know of is if are there any reference implementations at this point? If I wanted to go and grab Keycloak or something, could I drop in a DPoP implementation to kind of wrap my hands around it, or where's it at?
That is a good question. I'm actually not sure who has a current implementation at this point. But that is a good thing for me to make a note of, because that is exactly the kind of thing I should be putting on OAuth.net under the DPoP page, which is here. So,
Cool.
and you might notice that it is a little bit slim, not much content there. Some of them are a lot better. Of like, let's see, does this one have one? Nope. Some of these pages have a lot more information on them. Add yours. Some of them are stubs. So anyway,
Nice.
yeah. That
Yeah, that'd be
is,
good. I tend to understand things better from being able to sift through code and interaction in concert with things like specs.
Yeah, definitely.
But maybe that's something I could work on too as a side project. It's pretty fascinating. I wanted to kind of uh, speak back my understanding of it and have you validate if I have it right or not. The idea is that in the current OAuth world, we have these bearer tokens, and we have this kind of problem where if a bearer token leaks, anybody can use it, and whatever permissions that bearer token has now, whoever has it can make use of it, and the resource server doesn't really care. It is just validating the token. As long as it gets the thumbs up, it's going to respond. With DPoP, you have a new header, the DPoP header, and you have a JWT that's been signed with a private key that's generated by the application. And then the resource server would then use a public key to validate that JWT. So now it's a proof of the POP is proof of possession. So now even if that access token is leaked, there's no way for some rando to fake a DPoP header because they don't have the right key to do it. Am I on track there?
Yeah, definitely. That's the general idea. So the most of the time in OAuth, all of the tokens are considered bearer tokens. Even if it's a JSON web token, it's still a bearer token because that's all that's needed to use it. And yeah, so it doesn't matter if you've encrypted your JSON web token or signed it or whatever, it's still a bearer token because if it gets handed off to somebody else, it can be used just as well. So yeah, DPoP is the idea of proving possession, proving that you are the intended, possessor of that token. So, and yeah, it's usually using some form of signature verification in that model. And DPoP is a way to do it at the key difference with DPoP compared to other attempts at this is it's doing it at the application layer rather than at the transport layer. So another way to do it is through the TLS connection where the client can make a request with a TLS certificate, client cert, where the server can look at the fingerprint of that cert and associate the token with that fingerprint so that you have to keep using that same certificate whenever you use the token. And so from the client's perspective, you configure your HTTP client with the certificate, and then you don't change any of your application layer code, right? There's no code you write to do it. It's all done in your HTTPS stack, that layer of the stack. DPoP, on the other hand, the idea is to you write this into your application layer. So it's actually changing what HTTP headers are sent and things like that.
There's some complexity with client-side certs that we've just never been able to make easy because it's just never caught on. I was doing client-side certs for banks in the late 90s, and maybe that's a domain that it's still used in, but it just never caught on the way, say, server-side HTTPS did, and even in the last few years it's become even easier. So there must be, I don't know deeply like what the challenge is, but there must be some sort of challenge that it just hasn't really been made easy for developers or companies or small to medium-sized companies to be able to use, because there's a lot of applications for client-side certs and it's just never really taken off.
Yeah, it's really interesting. I do know that the user interface in browsers for client-side certs was never good, and like you would get the little pop-up being like, choose your certificate, and people are like, what? I don't understand. What do you mean? And that was a bad interface. There's definitely ways to improve that interface that could be done well and could kind of just remove that as the problem. And browsers never evolved that. And it's, I think, a bit of a chicken and egg situation, because the browser vendors have no reason to evolve that if nobody's using the feature, and nobody uses the feature because the user experience is so terrible. So someone has to go first of like, okay, well, we're going to use this even though it's bad now, because then hopefully browsers will make it better. But browsers don't have no reason to do that work until it's going to be actually useful to people. So
Right. I see the chicken and egg
yeah,
dilemma.
but even outside of the browser context, this is still definitely like doable today, because you can configure your HTTP client like in your code to use a client certificate. You know, every curl wrapper has a hook, like add in the certificate to the request when you make the request. And that's doable. There's no user interface concern there. And it's actually not even that bad from the developer's perspective either.
Yeah, that's a fair
point.
Point.
But the other challenge with that model is on the server side. So if you're using like a gateway, or you have any more complicated architecture than just a server, you are probably going to be terminating your TLS at some layer before it hits your application server, which means you need to do the check of checking whether the access token matches the certificate at the thing that's terminating that request, the TLS, which means it may not actually make it back to your application that knows about access tokens. So it makes that architecture a bit harder for deploying the server side of it as well. And I think that's another reason that mutual TLS hasn't necessarily caught on, because of those challenges. And then it gets even to be more of a problem, because in the case where you are using like Okta as your authorization server, but then you're building the resource server, because both of them have to be able to do that validation, right? So Okta is the one issuing the token for the certificate, but also it will be verifying like the token request that matches that certificate as well. And then your APIs have to validate that too, which is a lot more complicated than just check the signature of the JSON Web Token or go and do a token introspection request, because you can't like forward the it's a challenge. So I think
I can see that.
That's the reason that DPoP is being talked about, is because it changes where that verification is done, both from the client's perspective as well as from the server's perspective. So with DPoP, your browser client can do it, because you can write JavaScript code that does this, that creates the signature and manages the keys. And you can also do that from your server-side code. And then on your resource server on the API side, you can validate that because in your application, because it's just an HTTP header that gets forwarded through all the gateways that you might be behind. Yeah. So we'll see how it goes. I think that there's still going to.
I was just going to say, I do have one question currently about DPoP, which is how does the resource server know what public key it should be using? Is it like a JWKS kind of interaction? Is JWT, first of all, I guess, is JWT a requirement? It seemed like it was from my brief reading. And if it is, like, how does the server go about, because if I've intercepted an access token, I could go create a new JWT and sign it with a private key and send along a DPoP header. So
yeah. So the idea is that when the client makes the request for the access token, so this is going to be the OAuth authorization flow already happened before we get to this diagram, right? So the logging in and all that stuff. This token request is grant type authorization code, the authorization code from the query string, all those parameters get put into here. It also sends a DPoP proof, which is basically signing this request. So at this point, it's got a key. It signs this request, and then the authorization server says, great, here's an access token. And the authorization server keeps track of the public key that it saw, or the public key that it saw in this request. So at this point, the authorization server knows this access token is issued to this particular key. So when the access token is used at the resource server, the request also contains a DPoP proof, which is again the same, using the same key. The resource server has to be able to say, okay, first, is the token valid? And then does this proof match the key of the original token request? So coordinating between these two is it makes that a little more complicated. Of like, it's not the same as the introspection request. It's considered out of scope of the spec because these are often part of the same piece of software or whatever. But
implementation details,
yeah. But in the case of course, like Okta, that's going to require some coordination between your API code and Okta's authorization server.
Right.
Which I don't know exactly what that would end up looking like, but that's how it works. So if the client comes and brings a different key in this request, it would fail because this proof does not match the key in this proof does not match the key used in that one.
Right. That's cool.
Yeah.
Makes sense.
This is a good question, though. Doesn't DPoP increase the resource demand at the endpoint? Wouldn't that bottleneck stuff easily and leave you vulnerable to flood attacks? I don't know if it would necessarily bottleneck it so much that you can DOS the server by sending these proofs. The one of the goals of it is supposed to be quick to verify it, but it does definitely add more complexity at the resource server. So here is a let's see, is this where it's explained? No, the protected resource access. So when the client goes to make the request, it's going to also do this whole thing of like, basically this is what it ends up looking like. It's, here's my access token, and then here is the DPoP proof, proving that I control the same key that was used to issue the access token. And you have to be able to verify this at the resource server. So here's the explanation of how to do it. I'm trying to see if there's a quick description of it. No, I'm not seeing the quick description of it. The question would be, is it possible to verify that without adding a network request? And I believe it is possible because this is still a JSON Web Token, right? So you have to know what key to expect to find in the proof, which you would know somehow from the access token. That's the sort of hand-wavy bit implementation detail.
Right.
But if you know what key to expect, you can verify this and verify that it matches that key. So I'm guessing that one way to do it would be to, I wonder if one way to do it is to put some identifier of the key inside the token. Like if you're using JSON Web Tokens for access tokens also, which is not a requirement. But yeah, that's a signed JWT swapping. Can't create, message integrity. Nope, only contains proof. This is actually a good point too. The proof that's created, let's see, is there a description of what goes into the proof? The thing that is signed, here's what's signed. So you create a JSON Web Token, and it's going to include a unique ID. It's going to include the HTTP method, so post or get, the URI for the request. Interesting, it's without query and fragment parts. And then the time it was created, and that's it. So it's not signing the contents of the request. It's just signing the sort of like the metadata. And this was actually kind of a part of the discussion this week of there is a HTTP message signing spec being worked on also, which would sign the entire, well, gives you the ability to sign as much of the HTTP request as you want, including the body, if it's a post request, or any arbitrary headers as well. And that's a very different problem, and actually is a lot more complicated to implement because you have to deal with canonicalization of the request and all that kind of stuff. So this is intentionally, this is what it was saying down here. This is intentionally smaller scope problem where it is, where is it? Yeah, message integrity. It is an intentional design decision to keep it simple to use, but it does mean that replay attacks are possible with this actually, because if someone can intercept the JSON Web Token being used as the proof, you could use it again to make a request as long as that request matches the same stuff that's being signed. So you can't steal a JSON Web Token DPoP and use it at a different endpoint, but you could use it at the same endpoint. And because the body is not signed, you could swap the body out, right? So yeah, it's not perfect, but hopefully the idea is that it's better than not doing it.
Right.
Yeah.
Yeah, and it sounds a little, there's an aspect of it that feels a little bit like what happens with Pixie, in that it's the your client application that's signing the JWT, and that's not something that can be easily stolen, kind of like the like the code verifier for Pixie or something. It's generated by the application.
Mm-hmm.
So you should have some level of safety there.
Yeah. So let's see. Proof is more like signing the access level, meaning each URI has already been authorized by the auth server. Well, it's not really any sort of access control thing or authorization aspect at all. It's really just proving that the idea is that it's meant to prove that the access token is being used by the same thing that originally the access token was sent to. So that's it. So like Pixie is a good example of that too, where Pixie is basically, it's the same idea, where what Pixie is doing is it's making sure that the thing that is being sent to the access token is the same thing that started the Pixie flow, so that you don't accidentally send a token to a different instance of the app, for example. But then after the access token is issued, Pixie's out of the picture. So it's like if you had a way to keep that going throughout the rest of the lifetime of the access token, of making sure that the only thing that is using the token is the same one that it was sent to at the beginning. But I don't know, like this is obviously not a perfect solution. And the only way that it's actually gives you any real level of assurance is if this key that is used to make this proof can't be extracted. So if you are in JavaScript and JavaScript is probably the most, or actually no, a desktop app too. If you are generating a key in your application and then storing the private key in that application layer code, it can be stolen, right? If somebody has access to steal the access token, they probably have the same physical access that would let them steal the key if it's being stored in memory or in that application storage. So the way that you have to store it where it can't be stolen is in some sort of hardware security module, right? If the key is being generated in a way that it can't be extracted, then it can't be stolen, right? So the application can be tricked into signing stuff, but the application can't be stolen out of the application. So like in general, all these things, what they're trying to do is they're trying to stop the attack of, which is actually extremely common, of your browser is an application running on your computer and it's storing data somewhere on your hard drive. If someone has access to your hard drive, they can actually just basically clone the entire browser, right? You can grab the cookies out of the browser because they're on the drive somewhere. And if you pick up all of someone's Google session cookies, then you can drop it into your own browser and now you're just logged in as them. You've bypassed all MFA and everything, because MFA is only securing the actual issuing of these credentials. It's not securing the actual access. So once MFA is done, you've issued a session cookie or an access token or whatever it is. And if you can pick that up and find it and send it somewhere else, you're already logged in. So
Yeah,
this
it's a lot
is
sneakier to get at the, the data that the browser's written to disk than trying to attack the browser directly with a browser extension or something.
yeah, because like browsers are reasonably secure within themselves. Like they do a lot of work to ensure that cross-site scripting. Actually, there are a lot of browser APIs now to prevent even cross-site scripting attacks from working. But there's definitely a lot of stuff in there for like preventing hardware access from the browser or cross-tab memory sharing. Like none of that's a problem anymore, right? We don't worry about those kinds of things. But it's all at the end of the day written to your hard drive, and the OS doesn't necessarily have those same levels of protections. On iOS, you do, right? iOS, there's basically no way for apps to talk to each other, so that's good. But on a desktop, that's not the case. And the way this ends up happening is someone will trick you into downloading an executable file for through some sort of social engineering attack, and that file can then just pick up your browser and send it off somewhere and take over your entire Google account, which has absolutely happened many times, usually involving running crypto schemes on large YouTube channels.
Right.
Yeah, which happens again and again.
Video about that, right?
Yes.
Yeah.
I have seen several YouTube channels of people who I know being taken over through usually that scheme. Because yeah, you know, once you have a big enough YouTube channel, you're gonna figure out that you need two-factor auth and good security practices on your Google account. But none of that matters if they can get access to your actual browser.
Right. I think it's a vector of attack. Maybe it's not so much now with a little bit of time that's passed, but it's a vector of attack that I think was kind of neglected for a while. We spend so much time inside the browser protecting tabs from themselves and applications and, cross-site scripting and HTTP only cookies. And it's kind of genius in an evil sort of way to just bypass that altogether.
Yeah, exactly. So that's the general problem that all of these things are trying to solve. DPoP, MTLS, all that stuff, where it's trying to make it so that even if you do have access to the disk and can pick up someone's cookies or access tokens off of outside of the browser, you still can't use it because you need something that can't be lifted, which is a private key in a hardware security module, which thankfully is getting built into more and more computers now and phones and stuff. With Face ID and Touch ID, all those keys can't really be extracted. So being able to use those to create these signed proofs would then actually solve that problem. So the question is just, what's the easiest way to do it for developers as well as people running servers? And that is the big unknown right now. So DPoP is one attempt at solving that. With DPoP or MTLS, can we have large timeouts or no expiration? These don't really. The DPoP proof or MTLS proof isn't tied to token lifetime, so the token can still have its own lifetime the same way as it normally does, because it's going to be either a structured token like a JSON Web Token or just a random string stored in a database somewhere, and that can still have its own policies around how often that gets refreshed and all that. The DPoP or MTLS is just the idea that you have a key that you have to use every time you're interacting with the system, both the authorization server and the resource server. Could you then make access tokens that don't expire? I don't think it changes any properties of whether that's a good idea. I think still the same considerations of long-lived or non-expiring tokens still apply. Like it does theoretically reduce the risk of a token being used if it's stolen. That's the whole point of it. But that's not the only reason you don't want to do non-expiring tokens. Right.
Makes sense.
Yeah. How well is this integrated into
So
existing tools? I would say it's not at all yet. It's all still very much in progress.
yeah, there may not even be like a reference implementation for its current state yet, but that would be a cool thing to play with anyway.
Mhm.
But that seems like a relatively high bar to entry right out of the gate. And that is, I mean, that's at least part of the problem we have already with access tokens and browser applications, which is that the dirty little secret is that there's very few reliable, strong ways to store any kind of data in the browser. Uh, at least currently, are there kind of concurrent efforts to allow the browser access to hardware security? Is
Yeah,
that like
the
part of what WebAuthn is about?
so I haven't seen any APIs for like storing data with a key, like with sign with a key, but there is a an API, the Web Crypto API, which is a very low level API, and hopefully it's going to get better. But um, no, it's this one. So this one, what this lets you do is from JavaScript, you can generate a key, but the key is not it's stored in the browser and it can't be grabbed from JavaScript. So I don't
So it's like
know
in
if this
memory.
it's well, it's like it's kept track of by the browser, but JavaScript can't access the key. But it can generate a key, it gets an object to it, and then it has a way to run a sign. There's a sign method of like, please sign this for me. Um, there is an export function, but I'm pretty sure the generate key has a attribute. So you can say make it not extractable. So generate a
That's
key,
cool.
hold on to it, don't let me access the private key, but then you can run sign on it so that you can sign a message with it. Now,
Right.
whether that integrates with the computer's hardware security module is a different story, because ultimately
Right.
that key, if it doesn't integrate with the hardware security module, it's still stored on disk somewhere that can be extracted.
Right.
But what this does, at the very least, is it makes it so that cross-site scripting attacks can't steal the key, which is
Yeah.
a much more common uh, attack than someone getting disk access to your machine.
Yeah. I mean, you kind of have bigger problems if somebody has disk access to your machine than just the browser. But
Well,
yeah,
yes and no, because the browser is like extremely powerful and can do and usually has a lot of long-lived session cookies and things like that, and
right.
has already gone through MFA. So disk access to your machine, like the browser is probably one of the most highly valuable targets if someone has disk access to your machine. Because what else I can do is just like steal random files. Those don't do anything. And it's not like anybody has their
Yeah.
Bitcoin private keys on their computer either, right? So
Yeah, that's fair. So, but that subtle crypto seems like it would be directly useful for DPoP because
yeah,
that presumably is what you would use to generate a key and then be able to sign stuff.
yeah, definitely. And I did just find two libraries: a Go library for DPoP and a TypeScript library.
Oh, neat.
So I'm curious to see how this actually, what this actually does under the hood.
Yeah.
But this is how you use it, right? So you do generate a key pair, and then you can generate the proof JSON Web Token, which is like this is the idea: is that it shouldn't be that much code to actually use it, right? Once you got a library that understands how to create that signature, it should be as simple as calling the give me the JSON Web Token with this key, and here's what you're signing. You're signing um, the URL and the HTTP method.
Method. Yeah. That's cool. Definitely have to check
Mm.
those out.
So this one does not use that API because it says storage of the key is not part of this.
Mm.
So that would be a feature request for this library, is to use this
The web crypto.
library or
Yeah.
API to generate the key so that it doesn't have to be stored at the application layer.
Yeah. Cool. Well, let's talk about what else is coming up. I see inside of March, there's an OAuth 2.1 meeting and then another one that has some other interesting topics.
Yeah, so Monday is OAuth 2.1, and that is the ongoing effort to consolidate and simplify the specs so that there's just less stuff to read. And it's a huge effort, as we are seeing, but we are making progress. We're going to have hopefully some updates to share. We've done a couple of changes based on some feedback from people in the group so far. There's been some really good feedback of just a lot of it's just suggestions on how to rephrase sections and move things around to make it more clear, or suggest dropping some parts that are redundant or whatever it is. So that's been something I've been working on quite a bit. And yeah, there's been a new draft published, I want to say, not that long ago.
February 19th? Oh, no, sooner. Something in
Monday.
March, huh?
Yeah.
Oh, right.
And yeah, this is the new, there's a couple of more suggestions, one of which is to rearrange this, which talks about authorization code and client credentials, to rephrase it so that this is like how you get an access token. And then like this is the token request section, and you would put auth code, client credentials, and refresh tokens in that same section, because those are all token requests.
Right.
But a lot of this stuff is just like readability, right? It's not changing the spec. So
Yeah.
what we're going to be talking about on Monday, though, is stuff that is more in the actual like implementation differences or normative requirements kind of thing. So like how we address.
Oh, sorry. Go ahead.
No, go ahead.
Yeah, I was going to ask what drives what it is that you're going to talk about, because I know there's a lot of activity on the email lists in between meetings, but then somebody's got to come up with an agenda when you're actually the working group is meeting to say, okay, this is what we're going to focus on. So I know it's OAuth 2.1 generally, but what drives what you're actually going to talk about at the meeting?
I have to make that agenda after this happy hour.
All right.
Yeah.
Fair enough.
The editors, the three of us, talked about it on Monday, though, and we have our own lists of, it wasn't Monday, I think it was Tuesday. I don't know, this week has been weird. But we kind of came up with a list of like, here's the things we think are good talking points for the meeting. Here's things that we think don't need to be discussed because we all agree, or it's very straightforward and we're just going to make the change later. But the main things to bring up to the group are things where either if the three editors don't agree on something, then we need to get more input, either to have someone change our minds or decide to not do the thing or whatever it is. But if the three of us agree, we're generally like, yeah, we all have different backgrounds, so it's probably a good idea to do that. And some of the things are just like, yes, this paragraph would fit a lot better if it was in this other section. And we need to like bring that to the group for discussion.
Right. Cool.
Yeah. So that's 2.1. And then the Monday after that is two drafts: client intermediary metadata and multi-subject JSON web token. These are two new ones being brought into the group. You will notice individual drafts, not adopted yet. So the idea will be to, again, see if there's enough interest in the group to actually adopt these as working group items.
So what is this notion of client intermediary data, considering I see it's under the Parecki umbrella right now?
This one is one I've been working on, and I've been working with the Financial Data Exchange group. That's another it's another one of these groups that is adopting OAuth for a specific vertical, which is the financial industry, and it's primarily US based companies. And there's already been a lot of work done in the OpenID subgroup, financial API working group under OpenID. So a lot of what FDX is doing is just saying, we're going to take these other documents and adopt them as well. But it's basically a collection of a bunch of US financial companies that are deciding to work together on standardizing using OAuth in the financial space to avoid things like screen scraping and credential sharing. Because it is frankly embarrassing that when you go connect your bank account to various apps like budgeting apps or QuickBooks or TurboTax or whatever, you really should not be putting in your banking login credentials into those applications. It's embarrassing that it still works that way. So,
Yes.
yeah, we're trying to actually solve that. And there's thankfully a lot of people who agree that that problem should be solved. So now the question is how to solve it and what parts of OAuth do we need? What parts are a good idea for that? Obviously, OAuth is a framework and there's a lot of optional pieces. So it's kind of like a bunch of building blocks you get to assemble however you want. And this draft is basically filling in a piece that didn't exist in OAuth that they need, which is because, so like in normal OAuth, you would go, if you want to go access data from like the Twitter API, you, the developer of some application, just goes and makes an account on Twitter, signs up as a developer, agrees to their terms of service, and then you can get credentials for your application. And that's fine. But in the financial world, it's a lot more complicated than that. So if you have, for example, like, I don't know, QuickBooks wants to download transactions from US Bank. Well, Intuit is the company that writes QuickBooks. They don't want to go to US Bank and make a developer account because, and get credentials for QuickBooks online, because there's so many different banks, right? There's all these different banks, and they have to do it for every single bank, which is just too much work. And then QuickBooks has to do that as well as every other piece of software, right? So there's like too much of it, and there's also like not just, the banks also don't want to deal with those requests either. So instead, what ends up happening in practice, like this already is a thing, is there's these aggregator companies that kind of sit in the middle, and they will create these relationships with the banks and then sort of wrap the API and provide that data to end user applications like Mint or QuickBooks. So what it means is that it's like there's a whole bunch of these end user apps, there's a few aggregators, and there's a whole bunch of banks. And it means that there's a lot fewer cross connections, right? It's not every app talking to every bank. It's a bunch over here talking to a few, talking to a bunch. And
right.
The trick is that because this is the financial industry, there's a lot of regulations around data sharing agreements and things like that. And users have to be informed about things. And when you see this OAuth screen, it's you want it to say like QuickBooks is trying to access your data from US Bank, right? You want to end up with a screen like that. But you have to also say, and this data will be shared with X, Y, and Z because of all these different companies that are involved in that chain. And there isn't any mechanism in OAuth to specify the other companies in the chain or the fact that those should be displayed on the consent screen. And that's what this draft is doing. Basically, it's giving a way to associate the data of all the intermediaries that are going to be getting access to data when an application is registered. So once that building block is there, then they can take OAuth, this draft, a few other drafts, put some limitations on it that are described in the financial API OpenID group, and then they get a profile of OAuth that is useful for that world.
Interesting. Well, I mean, one of the companies that you're talking about, the intermediary company like Plaid, right now they do a lot of the scraping, give us your OTP kind of work. It would be really nice to see this evolve because, like you said, it's kind of embarrassing at this point that seems to be like the worst offender is the place that we have like our most sensitive, among our most sensitive information. The banks are so far behind, relatively speaking.
It's pretty bad. Like Google's security is way up there, and they are one of the best at protecting consumers and having a good OAuth experience and being really strict about it. And they don't hold on to your actual money. So I would actually much rather trust Google with like my bank account credentials than my own bank's login at this point. But yeah, hopefully with this we can improve that, and the US will finally catch up to it is already happening in a lot of banks in the US and a lot of the rest of the world. Is like a lot of them are using OAuth now, but but we still have a long way to go.
Yeah. Oh, cool. And I started digging into this the JWT
this one,
the related multi-subject, that was the word I was looking for.
Oops.
And I was kind of interested by it. And what stood out to me is that it's this notion that you still have like a primary subject, but then there are related subjects that get embedded. And it's cool, but I was left with like, and you may or may not know this because this isn't your spec, but like, what is the use case that they're looking to solve here? Because it's not just that you have a bunch of subjects, it's that these other subjects are related to the primary one in some way.
Mm-hmm. Well, I mean, there's this use cases section. So I haven't read this yet, actually. This is good prep for Monday. Primary subject with a related secondary subject that has authority over the primary subject, child, parent, pet owner. The secondary user logs in, asks for permission to access resources for the primary subject. The authorization server then issues a JSON Web Token with the primary subject in the enclosing JSON Web Token and the secondary in the nested. So I guess the idea would be if you're using JSON Web Token access tokens and you're using the subject of the JSON Web Token to identify which resources to look up, but you want to know that it was not that person who actually authorized it, right? So
Right.
in typical OAuth, the same person who owns the resources is the one authorizing access to them. So the subject of the JSON Web Token happens to coincide. It's both the person who logged in and the person who owns the resources. So this is for the case where those are different people. The person logging in is not the person who owns the resources.
Yeah, and the other one, the second one seems relevant too. Like the example is a married couple or a partner relationship. I mean, that's pretty common where, I need to go and get a prescription filled for my wife or something.
Yeah, you don't want to have to log in as her to do that, because that's misrepresenting what's actually happening. So this would give you a way to actually represent, I guess, what's really happening. Yeah, I am curious about this because it seems like there are multiple ways to solve this, and this is just one way. So it's looks like it's adding this claim, new claim, related subject that has a description of the relationship and then a JSON Web Token inside that describes that subject. So
yeah,
this is one way to do it.
so this is
you can imagine there's a
list of
these are just or, so it's
yeah.
You could say it's the authority over, so that's the pet case or whatever. But I mean, this is one way to do it, but you could imagine that you don't have to put a whole JSON Web Token under here. You could just put new claims under there, right? That's a different way of doing it with different properties, but those are the kinds of questions to ask about, why does it work this way? What's the intent?
Right. Is this the first time that it's
meeting.
being taken up at the working group?
I believe it is. Let's see. This was published in March, but version 0 was March last year. So, interesting. And that was a different working group. And then it got moved here. And then apparently Rafat changed companies between September and March.
One of our friends from Auth0 looks like.
I actually didn't realize that he is at Auth0. Yeah. Well, that is that week, and 4 more in April. So these are all, let's see, these 2 are in progress, have been in progress for a while. We've definitely talked about those. And then this one is a new, it's not actually a spec, it's a use cases document talking about how might browsers better be involved in identity and authentication, because right now they're not really involved. They're just shells that can be used to create authentication flows. So that's, and there's people from browser vendors who are actually like interested in working on this problem and improving that space and getting more, building more actual browser UI around authentication use cases. So we're trying to collect these use cases. And then this one, I'm pretty sure that acronym was not chosen accidentally. Token mediating and session. Yeah, see, the session should have been capitalized. They just left it out for the funny acronym. Token mediating and session information backend for front end. Oh yeah, and they capitalized the F. Nice, good one, good one, guys.
Cheating.
Yeah. But this is a brand new one. First published last month, and this is a new idea for how to coordinate between single page apps that do have a server-side backend, and it's describing some interactions there. So it's worth taking a look at, because people are going to have some strong feelings about that, I'm sure. So this is the time to chime in.
Is the goal of the security BCP one to continue to revise that while we're in between 2.0 and 2.1?
Yeah, basically 2.1 is supposed to include everything in the security BCP, but the security BCP still is useful as a reference for OAuth 2. So like we still want to finish that one, get that one done, and then everything in it gets put into 2.1.
Yeah. The TMI BFF one, I think, is particularly interesting because we have talked a lot about, if you have a use case where, or if you have an architecture where you have middleware, you're much better off keeping your tokens there than having them arrive at the browser at all. If you have a pure SPA app, maybe you don't have much of a choice, right? But if you have some sort of middleware, and I wonder, you may not know yet, but is the intention to kind of address that, to kind of codify that in some part of a standard, or is it totally?
Actually, it's the opposite. So the browser-based app spec that I started, which is a little stale right now, we need to go back and revise it. But that one describes the pattern you're talking about of do your OAuth flow from the server side, keep the tokens server side, and do a session cookie to the browser so that access tokens never make it to the browser. This is exactly the opposite. This is if you do the OAuth flow from the server, but then you explicitly give the tokens to the browser so that the browser can make API requests without going through its backend. So it's establishing that pattern. And yeah, we'll see what they say about it, because they brought it up on the mailing list when they first published that, but we'll see what the thoughts are around that. At the very least, it seems like I might have to add this a reference to this in the browser-based app specs as like a fourth option.
Right. Well, there's a lot of interesting stuff coming up. It may be useful because we've had a little bit of a gap of time to let people know how they can get involved if they're interested. The site that we've been looking at is events.oauth.net.
Yeah. And this is where we post these meetings, but sometimes other things on here too, like other the workshops or the IETF meetings, or where is it? Last all the happy hours I posted here. What am I thinking of? The Internet Identity Workshop That's another place that's it's a different group, but there's some interesting stuff happening there as well. The security workshop, which is again not IETF, but it's just a community organized event talking about OAuth security stuff, and a lot of good discussions happen there as well.
Gone back to the before times when we could actually travel around.
Yeah, yeah. When I actually went to Singapore and Montreal and Prague all in the same year. Yeah, so this is the place to go to find these, and these are like publicly available to join. So like you can absolutely join and show up and talk about things. There's no like apply to be a member button in the IETF. You can just sign up for the mailing list if you want and write messages or come to the meetings. It's very informal that way. Yeah, the IETF homepage for the OAuth group is, oh, there it is. I talked about this is where you find the other, this is the other place to find the meetings and stuff, but I find this one's a lot harder to navigate. But these are the list of documents that the group is working on, which is a lot.
Just a few.
A lot of in progress work.
Nice. All right, and so we'll be back here in 2 weeks. Yes? We doing every other week?
I think we might even be doing every week during this,
Oh, nice.
all this.
Yeah, there's a lot of activity, right? That would make sense.
Yeah, just because there's interim meetings every week for the next 6 weeks. So we will be here every week, except for Octane week, where Octane will be happening. So
yeah. Yeah, that's April 6th to 8th. So whatever that Thursday is, we won't be here. All right, well, we'll put it up on that events page anyway. And it's good to get rolling again. Good to be back.
Yep. And I guess we're at the top of the hour, so let's just wrap it up here and see you back here same time next week.
All right. Bye, everybody.